Hello, my name is Jason Chanko and I'm an applications engineer at RIGOL Technologies. Today we're going to be talking about the RIGOL M300 data acquisition and switch system. Go into a little bit more detail about the use cases as well as some of the options that you have available to you with the instrument. So here we have an M300 mainframe. I'm going to talk a little bit about what the M300 is designed for or what type of typical applications. Primarily burn-in testing. So if you have a number of devices under test that you want to burn in over a period of time, that's traditionally using an environmental chamber. Let's say you have 30 or 40 devices that you want to hold at an elevated temperature or temperature cycle, but you want to be able to either route multiple powers or power supplies, voltages, or currents to the instrument or devices under test, or you want to measure currents, voltages, or multiple temperature points in the device under test or in the equipment that you're going to be testing. The M300 is perfect for that and designed exactly for that. If you're just going to be doing bulk switching, each mainframe is capable of 320 channels. If you're going to be making measurements, so we're going to have a digital multimeter module in the instrument, then it's going to lessen the number of total measurements or total number of channels you can take down to 256, but still quite a bit, quite a dense instrument from that standpoint. Instead of having 10 digital multimeters, you can simply have a one switch card and one digital multimeter card in this package and be able to make 10 similar measurements than you would with 10 DMMs. So very flexible from that standpoint. I'm going to talk a little bit about the instrument. It actually has 5 slots available in the back. These are the front indicators that tell you which modules are installed in the back or whether there is a module installed or not. And when we fire it up, you'll be able to see the LEDs light. But again, slots 1, 2, 3, 4, and 5. We have a USB key or stick input on the front panel that is capable of being written directly to. So at the end of each scan, that data will go directly to a USB stick on the front panel. That can be extremely helpful for applications. If you're going to leave something for a weekend or you don't have a computer that can control the instrument, you can have the instrument write directly to that USB drive, standard CSV format that you can import into Excel. And there's even an option that would allow you to limit it to only writing 64,000 rows per scan, so that would limit that would allow you to use older versions of Excel also with the instrument. So that's very, very handy and a helpful feature there as well. There's 256 meg of internal memory. Again, you can write to internally or externally to a USB stick. You can also use an external digital multimeter if you wanted to not fill a slot with the digital multimeter, or you had a higher precision digital multimeter that you wanted to use. You could route that into the backplane externally. Again, I can show you those connections when we spin the instrument around. There are also 4 alarms available on each channel, so if you were to do a high or low measurement and put a limit on that, you can have an alarm through the digital I/O, control external circuitry. You can light a light or sound an alarm if something was to happen or one of those alarms were to be tripped. You can also monitor channels in a scan list, and then we have quite a bit of communication capabilities. And I'm going to spin the instrument around here in a second and do a little bit more of a description there. If you could just bear with me one moment. And so now we're looking at the rear panel of the instrument. What I'm going to do is remove one of these covers. Actually, I'll remove both of these. So what we've got here, we've got 2 slots that you can actually take one of the modules. Just back it away here. So here's a switch card module. Here is the external connection out to the outside world. And here is the connection to the back plane of the instrument. They are not hot swappable, but you can just, with the instrument powered off, you can just slide the card in, which is what we've done to these 2 cards here. You can see, I'm just turned a little bit sideways. So you can see here, we just insert the module in until it clicks, and we're all set. You'll notice that this module doesn't have a termination connector on the back. This is actually the DMM module, so this is inserted and used when you're going to be taking measurements. Again, if you don't want to make measurements and you're just routing signals, you don't need the digital multimeter module, but in most cases I think it's a handy addition. So we have the 5 slots available, and then we also have this communication and power input area over here. So it's got USB, LXI Ethernet connection, GPIB standard, RS-232, as well as alarms, so an external triggering. So if you're going to be using RS-232, there is a breakout cable here that allows you some access to these external triggers and alarms. And then there's also an analog bus control. And so that covers and then the standard power and power plug. Covers the back panel of the instrument pretty well. Again, we support all of these communication protocols. A lot of systems are still using GPIB, especially from an older sort of standpoint where you have test systems that are already operating in GPIB, completely compatible. We don't need to do any kind of conversion or anything like that. So now I'm going to spin the instrument back around, if you'll bear with me again.